Hello friends, so here we'll be discussing the fourth category, which is the classification of signal in terms of energy and power signal. Okay, this a very important classification. So before we discuss energy and power signals, let us try to understand a very simple concept. Okay, let us say we have a simple resistive circuit consisting of a voltage source and a resistor connected. A time varying voltage source, a resistance R, which leads to a time varying current. Here the power, the instantaneous power, drop across this circuit because of this voltage drop across the resistor, that is simply the product of voltage and current. Now here we can write either of these, this two parameters that are involved in it, we can represent them in two ways. First, we know Vt is equal to It into R, that, and It is equal to Vt by R. Both of these forms are correct. Let us say we use this one. So we write it as Vt as It into R multiplied with It. This is equal to I square T into R. One expression of power. In another expression, we write Pt is equal to Vt, and we write It as Vt by R. We represent it in this way. So this becomes V square T by R. Both of them are correct, this one and this one. When R is equal to 1 ohm, the value of this resistor is equal to 1 ohm. Okay, then here Pt will be equal to only V square T, and here Pt will be equal to only I square T. Okay, and this value of power for R equals to 1 ohm, that is equal to normalized power. It is called as normalized power. Why we use this concept? Because in electrical or electronics communication systems, we deal with mostly voltage and current signals. Whatever we handle the signal values, it is in the form of voltage or current. So here we can write this V square T is equal to I square T for R is equal to 1 ohm as X square T, where Xt is the voltage or current signal. Okay, Xt is the signal which we are dealing with. So this normalized power can be written as modulus of Xt whole square. This is called as normalized power. So we'll be getting the expressions of energy and power signals from this. Now, the total energy, okay, or normalized energy, it can be expressed as P is equal to E dt, we know that. Here we can write it as integration of this power Pt dt, but here we'll take the time interval from minus t to plus t with limit t tends to phi. This is the expression of normalized energy or total energy for this normalized power. Or we can write it as limit t tends to phi minus t to t xt square dt joules. Okay, now this is energy. Power is energy by time, so average power or normalized average power P, we can write it as, here it will be limit t tends to phi 1 by 2t. Why? Because we are taking both the negative and positive time durations from minus t to 0 to plus t. So that's why 1 by 2t minus t to t xt square dt, or this one. Okay, this P is equal to E by 2t. So we write this expression. Okay, and here this is for continuous time domain signals. Okay, continuous time domain signals. For discrete time domain, for discrete time sequence, we will have the integration in this expression replaced with the summation sign, and it will become n equals to minus phi to phi xn whole square, where xn is the discrete time sequence, and power will be simply limit n tends to phi 1 by 2n plus 1 n equals to minus n to plus n xn square. This is for discrete time sequence xn. This is for continuous time domain signal xt. Okay, so this is the expression of energy and power signal. Now we know that here the power is given by this E by 2t. Suppose this energy value, it has a finite value. Okay, it has a finite value, that is, it lies in between 0 and infinity. Here t, it is taken over an infinite interval. Okay, it is taken over an infinite interval from t equals to minus phi to phi. Okay, limit t tends to phi minus phi to phi. So obviously when there is phi in the denominator, it will be E by infinite, it will be 0. The average power or normalized power will be 0. So these 2 points are very critical. Always remember, average power 0, normalized energy, it has a finite value. These 2 points. If a signal has a finite normalized energy value or finite energy value, but power is 0, okay, power is 0, then it is called as an energy signal. Okay, energy signal means finite energy value, power is 0. 0 power, finite energy, that is energy signal. Okay, now suppose we have a signal where energy is infinite. Okay, infinite. So here power here energy 2t. This is infinite, this is also infinite. So if you have you're aware, we use various mathematical techniques when there is both infinite and both a numerator and denominator. We continuously differentiate it using L'Hospital rule, and there are other techniques as well. That leads to a finite power value. Okay, the average power is finite. The average power is finite, but energy is infinite. Energy E is infinite. These two combinations, that gives us a power signal. This gives us a power signal. Okay, always remember, energy signal here, energy is finite, power is 0. Okay, power is 0. Power signal, power is finite, energy is infinite. Okay, this. Always remember that. The definition of an energy signal is if a signal has finite value of energy but average power is 0. Here we are talking about normalized energy and normalized power. But generally it is expressed as only the energy and power. Next, for a power signal, okay, if a signal has finite normalized power or only normalized average power and infinite normalized energy or simply infinite energy, then it is called as a power signal. Okay, example, non-periodic signals are generally energy signals and periodic signals are examples of power signals. Okay, this is example. Another interesting property of energy and power signal is that both energy and power signals, that they are mutually exclusive. That is, no signal, there is no such signal in existence which is both energy as well as power signal. It is not possible. A signal is either an energy signal or power signal. And also it is possible that a signal, it does not satisfy the conditions or properties of energy or power signal. So it can be neither energy nor power signal as well. Okay, a signal can also be, okay, a signal can neither, such a thing is also possible. So a signal can neither be an energy signal or power signal. That is also possible. Okay, but it can never be possible that it is both energy as well as power signal. It is not possible. A signal can either have finite energy, zero power, which is the criteria for energy signal, or it can have finite power, infinite energy, which is the criteria of power signal. But it cannot be both. It cannot be both energy or power signal. And it is also possible that it does not satisfy any of these two, properties, characteristics, and it is neither an energy or power signal. Okay, so these are some of the important concepts associated with energy as well as power signal. So we'll be solving some questions, some problems related to it, so understand it in a better way. Okay.